Welcome to the 2020 Great Basin Astronomy Festival. My name is John Barentine, and I'm the Director of Public Policy at the International Dark Sky Association in Tucson, Arizona. I'm also a founding member of the University of Utah Consortium for Dark Sky Studies, which has a particular interest in dark sky issues across the West. And tonight I'll be talking to you about our heritage of dark night skies and why it's important that we protect them, especially in the context of national parks like Great Basin. So since we're going to go on a brief journey together, here's how we're going to get there. First of all, I'm going to talk to you about why Great Basin National Park is special, and particularly with regard to its naturally dark night skies. Second, I'll tell you about how we're losing this resource around the world. Third, how that change is impacting places like Great Basin. And lastly, I'll discuss the problems that are involved and the solutions that we know that are safe and cost-effective and result in the protection of places that we love, like our national parks. So first, why is Great Basin special? If you've been to the park before, I don't have to tell you why Great Basin is special. It's one of the most remarkable places in our U.S. National Park Service system, and its nighttime skies are spectacular, which largely has to do with its relative isolation from the major population centers here in the West. So if you go to Great Basin at night, you're likely to see scenes like this, where there are numerous stars in the night sky. You'll see the Milky Way. You'll see faint meteors and night sky phenomena like that. Hopefully you won't shine your flashlight up into the night sky for too long, like in this picture. But the foreground will be dark. You'll see the silhouettes of things against the sky. Because it's so dark out there. You might hear nocturnal wildlife active at night, for example. But coming to a place like Great Basin, you can enjoy scenes like this in a context that's it's safe. It's a safe place to be at night and to be able to view the night sky. So this is an increasingly difficult thing to find in our world now, where you have a night sky that is so naturally dark. And it gives you an idea of why I think we should protect places like Great Basin for that reason. To give you some context just here in the United States as to why Great Basin is special in this regard, here's a map of the lower 48 US states, over which I've laid a series of colors that indicate something called the artificial light ratio. And what that means is it tells us something about how much human-caused light there is in the night sky relative to an assumed natural level of light. So if you were to go to a completely dark place out in the middle of the ocean, as far from humanity as you could imagine going, the sky is not perfectly black at night because there are chemical and physical processes in the Earth's atmosphere that emit a little bit of light. And also there's the light from the cosmos, from stars and the Milky Way, et cetera. So if that's our reference for a natural night sky, what the artificial light ratio tells us is how many times brighter than that is the night sky in a given part of the country or in the world. And we derive this from satellite measurements of the Earth at night. I'll show you a little bit more about that in a few minutes. But what you need to know about the colors on this map are that as the colors get warmer, it means more light in your night sky and therefore more difficult to see the stars. And so the places that show up in the warmest colors, pink and almost white in some cases, are the biggest, most densely populated cities in our country. Whereas if you want to find the natural darkness, which are the areas in black and sort of gray, you'll notice that you have to go to the western part of the country. If you're east of about the Great Plains, there's basically no remaining natural nighttime darkness left at this point. It's just under too much pressure from our cities, even in very rural areas. And if you want to find large areas of natural nighttime darkness, you really have to come out here to the west. So to give you some context, the arrow here points to the location of Great Basin National Park, which is in this region called the Great Basin Province of the Western US. It takes up a large part of the state of Nevada and a little bit of Utah. And in terms of these, what I call pools of natural darkness, these areas on the map that are truly black, it's really second in size only to a region that's sometimes called the Oregon Outback in southeastern Oregon, off to the northwest, is that larger area in black. But the Basin and Range Province is one of the most important reservoirs of this resource that we now have. So keep this map in mind. If you're looking for a naturally dark night sky, At this point, basically, you have to come to the West in order to see it. And so Great Basin is not only special for its geographic situation with respect to those cities and the fact that it's dark at night, but it's special because you can come here anytime. It's accessible to the public at night. It's someplace that is protected for its night skies, so that we hope that that will persist. And also, if you come to the park, you have opportunities to have that night sky interpreted for you. So you can come to a ranger-led astronomy program, for example, or sometimes they have amateur astronomers will bring telescopes to the park, and someone will explain to you what you're seeing. So it adds to an element to the experience by better understanding what it is that you're seeing in the night sky. And there are relatively few places that do that. And I think that's another reason that really Great Basin National Park is a special place in that regard. And as of a few years ago, Great Basin is certifiably special. In 2016, the park became one of our international dark sky parks. And at the time, there were only 34 in the world. So it really is a special honor for the park to have achieved. And again, it's part of this idea that the land is protected, or, you know, we're managing this resource actively in this case in the interest of protecting it and preserving it for future generations, so that later on, decades or 100 years from now, people from the United States and across the world will be able to come to places like Great Basin and still have access to this wonderful night sky. But of course, it's not always been that way, right? Things have changed. The world is growing up. It's becoming more urbanized. People are increasingly settling into cities. And it's difficult to see the night sky in those places because there's so much human caused light on the ground. So think back to the map with the extent to which humans are lighting up the night and how that has affected so much of our own country. But it wasn't always like this. And you have to think about what people did at night in order to understand this a little bit better. And when I give this talk publicly, I always kind of go around and ask how many people remember, you know, what do you remember whether there was a time before the internet, for example? And people kind of laugh at that a little bit. But I'm getting them to think about what people did at night after the sun goes down, after they come inside. And, you know, we used to sit around here in the West and watch television at night. And I'll ask how many people remember a time before there was television. And, you know, the number of hands goes down pretty considerably. And I ask, what did people do? And somebody will say, well, we listened to the radio. And I'll say, well, does anybody remember a time before radio? And at that point, there are no hands up anymore. But and I say, well, what else did you do? And people might say, well, we read books. And then I'll say, well, there was a time before there were books. And there was a time before we lived indoors. And there was a time before we lived together. We were more of a nomadic society. And for a very long period in human history and prehistory, what we did was we sat outside at night under campfires and under the stars. And the scene that is in this picture is representative of so much of human history and prehistory. Every human once shared this experience. We would sit around the campfire at night for a number of reasons. It provided warmth and light. We could cook our food. It would keep predators away, but it helped cement the bonds between humans that resulted in human culture and our interdependence on one another. And this is where we think a lot of our folklore probably started, was around gatherings like this, around campfires. But later on in the evening, as the fire begins to die down, people looked up into the sky and they would have seen this. Every human in every part of the world would have had access to this absolutely spectacular night sky that was not yet impacted by light from human activities. And as is our tendency, because we're very good at picking out patterns and things, our visual systems and our brains are very well adapted to that. Humans began to connect the dots represented by the bright stars in the night sky, and they found familiar figures among those, what we now call constellations. So as an example, here's one of them. This is the constellation in the Western tradition that's called Orion, and it's shown in a 17th century European star map. Orion is sort of a generic hero figure, or it has been seen that way by many world cultures down throughout human history. Those stars are not arranged in a way that's meant to be reminiscent of a human figure. But again, we're good at sensing the patterns. And a lot of world cultures have seen what looked like a human figure among them. And so we projected our stories, our hopes, our dreams, our fears onto the night sky. And many of the constellations and the stories about them relate back in some way to our human motivations. So it's part of our relationship with the night sky in some ways that we projected our humanity onto the stars. And it goes without saying that the natural night sky has inspired countless generations of artists and poets and musicians and authors. And I've given you just a selection of some of the visual works of art that have been inspired by the night sky, beginning with an object in the upper left-hand corner called the Nebras Skydisk that dates to Bronze Age Europe about 3,500 years ago, all the way to the 20th century. And the picture in the lower right-hand corner called Starlight Night that was painted in watercolor by the American artist Georgia O'Keeffe in 1917. So this is something that still looms large in the human psyche and inspires and influences the creation of artistic works. But again, we're losing that gradually, which I'm going to tell you about. One has to wonder if these artists would have been inspired to create these works now if they lived in our cities, for example. So as I suggested, we are beginning to lose that night, that natural night sky, and all of its inspiration and its beauty and its wonder. The way I put this usually when I give a public presentation is to show a scene like this, which is a nighttime photograph taken across the Los Angeles Basin in California with the caption, "Now we see through a glass darkly," which is rendered sort of ironically compared to its original biblical context, where it was describing something that was difficult to see because there was something dark and sort of shadowy in the way. And it's ironic in the sense that now we can't see in this picture what's beyond, which is the night sky with all of its stars, because there's something bright in the way. And this is a phenomenon that we call sky glow. So what's happening is that sources of light in the foreground in this picture that are aimed or reflected off the ground into the night sky scatter off of small dust particles and air molecules, and that redirects that light in other directions. And in this case, some of it ends up in the photographer's camera lens. And the result is that it is difficult to see the stars beyond. It lowers the contrast between the stars and the dark sky beyond them. And so in this picture, whereas we should see dozens or hundreds of stars, we only see a few. So this is what our cities are doing to our night skies. And it's not just limited to the area immediately around them. The situation is very far reaching, as I'll show you a little bit later in the talk. So you will hear me use a very general term to describe this phenomenon, and that is the words light pollution. And there's no universally agreed on definition of what that is, but this is a definition that I like because I think it encompasses the idea pretty well. And it's the sense that there is some sort of negative or adverse effect or an impact that's attributable to the use of artificial light at night, that is, light that's caused by humans. And so we see it manifested in a number of different ways. If I talk about light pollution, this is what I mean. So what are those ways that light pollution manifests? One of them is sky glow, as I showed you in the slide previously. But these are some other familiar ways that we see light pollution, and they all fall under that heading of an adverse impact or effect of artificial light at night. And they're as familiar as this phenomenon we call light trespass in the upper left. You see there's a artificial light that's shining on a parking lot over on the left side of the image, and the light is shining on the house at right, shining in the windows at night. The neighbors probably don't appreciate that very much. But it's other things like using too much light. So to suggest that, I have a picture of a car dealership at night where the sales lot is brightly lit. But there are other forms like light clutter and glare. So if you come into an unfamiliar city at night, you're trying to find, say, road signs, but you have all these sources of light shining in your face, and it becomes difficult to find those landmarks. Or in the example of glare, everyone has had this experience of coming around a corner on a dark road at night. Somebody has their high beams on and they don't turn them off fast enough, and you're just temporarily blinded by the intensity of the light coming from that car, because that light is going directly from the headlights into your eye. It's not lighting up the road. It's not providing for safe travel. And in fact, it may be conveying a disadvantage on you, because now your pupils constrict, your depth of field is reduced, and it may make it difficult for you to see the road. So these are all examples of light pollution, and any effort to address the problem would address all of these issues included in that. So what's causing this ultimately? Well, again, it's the sense of human-caused light, and in particular, light that doesn't have a use to it, or it's not an efficient use of the light. So our answer to this is what I call artificial light at night, or sometimes I'll call it ALAN for short. So if you hear me use the word ALAN, that's what I mean. And in this slide, the intent is to show that there are two contexts for artificial light at night. One of them is distinctly outdoor. So the picture in the upper right shows the skyline of New York City. You see lots of light from buildings, light from street level. Some of it's reflected in the river in the foreground. That's mostly what we're going to be talking about for the remainder of the presentation. There is an indoor context for artificial light at night that's suggested by the picture at lower right of the fellow staring at the computer screen late into the night. That's a separate talk. We are concerned about the impact of indoor light at night as it affects us, especially relating to our health. But for the most part, I'm going to be talking about the outdoor sources of artificial light at night. So what do we know about light pollution? Well, these are some facts that were gleaned from a 5-year study based on orbital satellite data from the early part of the last decade, in a paper that was published in 2016 called The New World Atlas of Artificial Night Sky Brightness. And these are just a few facts that are picked out of that paper. The one that stands out to me is the last one, which is that the majority of people living in Europe and over half of the US population experiences what we would call perpetual twilight. So where they live, their night skies never get down to what we would call astronomical darkness at night. It's more like the twilight period between sunset and darkness, or on the morning side as it's getting light before the sun rises. The level of light in the sky is more comparable to that than it is true nighttime darkness. So that's a lot of people that don't really have access to this resource really at all. I can also tell you that the use of artificial light at night is global, and it is growing out of control. This is probably the most technical slide that I have in the presentation, so bear with me here. This is a figure from a paper that was published a few years ago in a reanalysis of the New World Atlas data that I mentioned in the previous slide. And here the authors have broken it down to individual countries around the world. And on the left side, they're looking at the fraction of a country's landmass that is affected by artificial light as seen from space. And then on the right, we're looking at the quantity of light that the satellite senses. And the countries are color-coded by how much that changed, either of those parameters changed during the study period. And in the middle of that is kind of a yellow color that represents no change. So if you're the United States, for example, surprisingly, the amount of our landmass that shows indications of light was not very different at the end of the study period as it compared to the beginning. And the same is true for the quantity of light. But you'll see that a lot of countries on both maps are in the oranges or red colors, which is indicating positive growth in those quantities. And in some cases, it's in the double digits in terms of percent change per year. For both of these quantities, for the area and the amount of light, the radiance, if you average it over the world, in the last decade, they were both growing at the rate of about 2% per year. So that's a pretty serious change. And in many cases, people have seen the night sky lost even within their own lifetimes. So this is telling us a lot about what the state of the world is in this regard, and that most countries are kind of growing in the wrong direction. So why does all this matter? I could give you a complete hour-long talk about any of these subjects, but suffice to say that artificial light at night and light pollution touches on every one of these subjects. And if we added indoor light pollution to it, we could also talk about the impacts to human health and well-being. But in outdoor contexts, these are kind of the four big topics that we encounter most often. But it also means that if we address the problem that underlies light pollution, that we could see important positive benefits in each of these areas. So just keep in mind that light pollution is more than whether or not that we can see the stars at night. And it's really about this sort of more holistic view of the world and how all of this wasted light at night is impacting our world. Can we make this better? We do think so. And that's something that I'll come back to at the end of the talk. So how is a place like Great Basin specifically affected by this? I showed you a map earlier that suggested that it was so far away from the bigger population centers that the sky was very naturally dark. But I want to suggest to you that it's not perfectly safe, and that even light from distant cities is beginning to impact places like Great Basin National Park. So to illustrate this, I want to show you some information that was provided by the U.S. National Park Service. This is a map of the night sky that was made by a group within the Park Service called the Night Sky Team. And they go around to national parks and monuments with a very sophisticated, calibrated camera system that takes images of the night sky in small pieces and then stitches them together to show a complete view. So imagine you're standing under the night sky, which is kind of like an inverted bowl over top of you, from the horizon up to the top of the sky. So let's say that we were able to kind of flatten that out on a surface. So think of the similar problem of how do we take a spherical or a round Earth, but represent it on a flat surface on a map. So that's all we've done here, is we've sort of unrolled the night sky onto a flat surface. So in this picture, the horizon runs across the bottom as sort of a straight line. And then that sort of oval dome shape shows you the extent of the night sky. So the zenith, or the top of the sky, is at the center top of the image. And what we've done here is we've color coded this map according to how bright the night sky is. And as the colors get warmer, kind of like with the map that I showed you earlier, the night sky is getting brighter and brighter and brighter. So you see there's a lot of blue and purple in this image, which is great. That means a very dark night sky. The most obvious thing that you see in this image is this kind of faint band of more sort of turquoise or cyan colored, even green and yellow light. This is the Milky Way that stretches across the night sky in this image. But you can also see some green down here along the horizon in certain places, and that's what we're after here. All of this other light up here is natural. We want to see this in the night sky because that's representative of what it would be in the absence of humans. So let's say that we take this image, we come up with a model for this natural light, including the distribution of light of the Milky Way and some of these other sources of light that are here. And if I subtract off that model, so I just remove the natural light, I'm left with only the human-caused light. And here it is. So now you see that we've made the rest of the sky black. And what we have left on the horizon are these blobs of different colors, from purple, blue, green, etc. So that's where all the cities are on our horizon. And they vary over large distances. So if I put some labels on here, this is what you're seeing. And some of those cities are as close by as the little town of Baker, Nevada, just outside the park boundary at 15 miles away from this location. But you can see in some cases that these cities are over 100 miles away. The cities in southern Utah, for example. And in particular, the biggest one of all, which is Las Vegas, which from Great Basin National Park is, as the crow flies, a distance of almost 200 miles. But if you go up onto the slopes of Wheeler Peak, for example, and look to the south, you're going to see this light, even over that great distance. So let's pick out Las Vegas for a moment. There's a famous ad campaign for Las Vegas that says, "What happens in Vegas stays in Vegas." Sure, you've heard of it. And what I'm going to suggest to you is that, at least in this case, that is not true. That what is happening in Vegas is not staying there. And that's why we were able to see it from a place like Great Basin National Park. So what's not staying in Vegas? It's light. Here's a little section of that map that I showed you early in the talk. This is that artificial light ratio. That's telling us how many times brighter the night sky is due to human caused light than it would be just due to natural sources. And I've centered it on Las Vegas. It looks like this bright bullseye here in the center. And I've drawn a white circle here whose radius is the distance from Las Vegas to the middle of Great Basin. That's at 195 miles. So you can see this little green outline up here is the park, and the white circle intersects that. So if the Earth were otherwise flat, if it didn't have any topography, we would expect that the light from Las Vegas is seen at least over a distance represented by this circle. And all of the things in this picture that are outlined in the thin green lines, those are all units that are managed by the U.S. National Park Service. So you can see quite a few parks, including all of Grand Canyon, is inside this 195-mile radius. I can tell you that if you've ever been to the Grand Canyon, either at the south or north rim, if you look down the long axis of the canyon to the west and it's a clear night, you can also see the glow of Las Vegas on the horizon. So this gives you an idea of the overall impact of of Las Vegas on the southwestern United States in terms of its light, which is an area of at least 120,000 square miles. And if you now add in the light from Los Angeles down here in the corner, and Phoenix and Salt Lake City and other areas, you can see why increasingly these dark areas like the Basin and Range province are really being squeezed by the influence of our cities. So why is all this happening ultimately? I think it comes down to these three very simple ideas. We have legitimate uses for artificial light at night, and we will continue to have those legitimate uses. But I think that we use vastly more of that resource than we really need to accomplish what we say we need that light for. And a lot of that overuse is just wastefulness. If we perceive light to be cheap and harmless, then we're probably going to use more of it. And I think ultimately too, that sense of wastefulness just results from a lack of awareness. And that if people consciously thought more about how they use light, they would find that they needed less of it to accomplish the same goal. And that we could make the nighttime world a better place simply by making better use of the light that we already have. So in the last part of the presentation here, I want to tell you a little bit more about the problems and suggest some solutions, and to tell you further that there's a part that everybody can play in this, and they're very simple things that we can do to solve this problem. So I always show this slide in my public talks when I'm speaking about light pollution, and I'll ask the audience where they think this is in the world. And first of all, to give you a little bit of context, this is an image taken by an astronaut aboard the International Space Station, looking out the window of the space station while it's on the night side of the Earth. Our astronauts on our space station can see the world's cities very brightly at night. They're only orbiting a couple hundred miles above the surface, and they can very easily take pictures of them. The astronauts are constantly taking photos with handheld digital cameras out the windows of the space station, and they love to take these nighttime photos. So I'll ask people where they think this is in the world, and I'll even give them a little hint. I'll tell them that it's in Asia. I get a lot of interesting ideas. People think maybe this bright mass of light down here in the lower right corner is a place like Hong Kong or Singapore, a very big city. They also think that this is an island. But then if I put some boundaries and labels in here, you quickly realize where this is, and understand that the thing in the lower right isn't an island. It's the peninsula of Korea, and in particular, it's the country of South Korea. And that all of this relatively dark space above and to the left of it is the country of North Korea, which is seemingly dark almost until you get to the international border with China. And the reason that I show this picture, which is shocking to some people, and sometimes if I put this up with the labels, you'll hear audible gasps from the audience because they can't believe that there'd be such a huge difference in the amount of light consumed between two neighboring countries. But I put this up to suggest that this is not our preferred way of solving the problem of light pollution. Of course, the people living in North Korea are hugely disadvantaged because of the government there, relative to their kin that live in the south part of the country. This is really a disparity of a lot of things. It's economic, it's social, it's cultural, but we don't want to make the world dark in this respect. We don't want to take away something from people when we know that it has important value to them. And certainly we want them to create the change that we seek through democratic means. We don't want this imposed on anybody. So instead of suggesting that we just turn the world's lights off, which is not a good solution, how do we realistically solve this problem? Well, we've boiled it down to just a few simple ideas that are represented by this infographic. And if we thought consciously about each of these elements of lighting when we were making choices about how we light the world, I think we could solve this problem within a generation or even more quickly than that. And it's just basic conservation ideas. You know, light is a resource. It has negative effects if we use it in the wrong ways. If we're careful about how we use it, we can really minimize those impacts. And we can get the most utility out of the resource by doing that. So there are things like confining the light to only the places where it's really needed, like in item 1. Only using the quantities that are necessary and not any more, and being careful about energy efficiency too. We think that energy efficiency is a great idea. We just don't want people to go overboard and think that because their lights are energy efficient that they should somehow use more of them. One of the easiest things that we can do is over here in number 3 is shielding lights and pointing them down, keeping the light on the surfaces where it's needed and out of the night sky. Ensuring that light is only used when it is needed. We can do this with things like timers and motion sensing switches so that the light is there when people are present, and when they're not, it turns off. We also encourage people to choose warm white lamps. We know that colors like blue especially are very harmful to the nighttime environment, and they contribute the most to sky glow, so that if we choose warmer lamps, we'll have less of a problem when that light does end up in the night sky. And lastly, to be respectful of our neighbors, we really should keep light on our own property so that we don't create conditions of what I described earlier that's called light trespass. Not only is this more considerate, but it leads to fewer problems among neighbors. So if we keep our lights shining on our own property and observe these other elements, we could really drastically reduce the amount of light that we need to properly light our world. It would result in a lesser of an environmental impact. It would be less expensive. It has a lot of good results if we're just mindful about how we use our light. So I'm often asked, does this work? Let's say that you follow my prescription that I've laid out here. Do we actually see things change when people proactively think carefully about how they use light and find that they can accomplish the same goals with much less of it? And the short answer to that is yes. We've studied that here in my own city, in Tucson, particularly in the last few years when our city converted its old street lighting system over to new LED technology, which has probably come to your town. And if it hasn't, it certainly will in the next few years. But we have a lot of astronomical observatories in the area around Tucson, and that's a contributor to our economy. So our city officials were very mindful about that when they designed our new lighting system. And we drastically reduced the amount of light that the system emits as part of that process. And we went out and we measured it. We looked at the condition of the night sky over Tucson before and after the conversion, which is represented by this figure in the upper right. The image at left is an image of the night sky with a fisheye lens. So we're seeing the entire night sky at once from one of our observatories near town before and after the transition of our street lighting system. And again, the colors correspond to how much light there is in the night sky. Blue means dark, green, yellow, etc. mean brighter. And this swath of green light down here in the lower left of each of these images is in the direction of the city of Tucson. And you'll see that between 2014 and 2017, that color-coded area got a little less green. The city was emitting a little bit less light. We also checked that with satellite measurements. The set of images along the bottom here, A and B, represent how bright Tucson was during the same period as seen by the satellites. And if we take the difference of those, if we subtract 2017 from 2014, we see that what's left is a lot of darker gray shaded colors here, which on this scale means less light. So we found that the amount of light over Tucson as seen in our night sky was reduced by about 7%. And we did that while maintaining the brightness of our streets above the recommended minimum levels by lighting engineers. Our streets are still quite safe. Our crime statistics, all of those other things that go along with light, don't seem to have changed since we got our new lights. It really was win-win-win all the way around. And by using less light, we're using less electricity. It comes at a lower cost to the community. It preserves public safety, preserves our night sky. There's really a lot to like in this solution, and it benefits everybody. So if you ask whether these ideas work, we have evidence that yes, indeed, it does. So I want to end where I began, which is this idea that Great Basin is a special place. And it truly is for all the reasons that I've described. There has a lot of qualities that set it apart from other places in the US and the world, both day and night. But its nights are particularly special. But the thing that I want you to take away from this presentation is the idea that Great Basin is not just special, but it's threatened, that even the most remote and we think best protected locations in the country are still susceptible to light pollution. And that will be a factor in the future as our cities continue to grow. So I want to leave you really with this thought, which is that the future of Great Basin night skies really depends on the choices that we make today. And that includes the choices that are made in cities that are many, many hundreds of miles away from parks like Great Basin. So if you think that if you live in a city and you're somewhere far away from a park, that your activities aren't impacting it, well, they are. But again, I've shown you some solutions that we think are simple, they're cost effective, they're safe. They make nights better at night in cities because we get better visibility, keeps more of the light on the ground out of the night sky and away from our national parks. So that if we just make a few reasonable changes in our cities now, that we can really protect places like Great Basin for the benefit of many, many generations yet to come. So with that, I thank you for your attention, and I hope that you enjoy the rest of this year's Astronomy Festival. Come see the park at night sometime. It really is an amazing place. Thank you.